Hello guys, Mr. G here with another video for the grade 12. This time we're going to be doing a test on vertical projectile motion, and it may be divided in two parts because I don't want to make videos so long as I said before. This time we are going to be doing some questions that are a little bit challenging, some of them. The question one is a multiple choice, and it said a stone is thrown vertically upward and returned to the thrower's hand after a while. Which one of the following position times graph best represent the motion of the stone? Ignore the effect of a resistance. I want you to remember that if we use the ground as the reference point, the object is going to move in the following direction as it moving up. And this is taking the ground as reference point. So the object will move in this way, and that is going to be as it moving up. This is moving up, taking the ground as reference point. Okay, so that is moving up. At this point here will be the maximum height. This is H maximum. The object stop for a second and then go all the way down, and this is the shape for the object to go all the way down. So saying that the correct answer is going to be C. We did this there was a video done on graph. Please, you can go and watch. I leave the link around here. So that was sorted. It's not too bad. Let's go to question 1.2. Now question 1.2 say two spheres, X with a mass of 4 kg and Y with a mass of 2 kg are released simultaneously from the same height h. Each one of the spheres experiences an acceleration due to the earth due to force. Ignore the effect of a resistance. And here is the picture of the two balls moving down. They will be dropped from there and will go all the way to the surface of the earth. Which one of the following is the correct relationship of the force acting on each sphere and the acceleration of each sphere? And they give you options there. Now, before anything else, independent of the mass of the object, each of them will fall with an acceleration which is equal to g and 9.8 meters per second square, approximately 9.8 meters per second square. And this will happen without having in consideration the mass of the object or anything else. So both of them will have the same acceleration. So if we go here, now we can already select two possible answers. The answers could then be either A or D, because the acceleration you can see that are equal. So either of them could be the correct answer. But now we're going to the force. We are going to the force. The force acting on both objects is the force of gravity, and the force of gravity or weight is equal to the product of mass multiplied by the acceleration due to gravity, which is that one there and is constant and the same for both objects. So saying that, which one will have the greater force of gravity? The one that has the greater mass. The one that have a greater mass will have a greater force of gravity. So Fg in X is going to be greater than Fg in Y. Not so for the acceleration of the gravity, because the acceleration due to gravity is the same. So saying that Fg in X is greater, so we are working with this one here. So A would be the correct answer for this question, and D is not possible to happen. So we can now go to question 2. Now, question 2 said two bodies are on a bridge, 200 meters height, throwing stones to the river. One boy throws stone A with initial velocity of 5 meters per second downward, and 1 second later, the other boy throws a second stone B with initial velocity of 20 meters per second downward. Ignore the friction, define the term free fall. And we can answer that question right here. Now, free fall is the motion of an object with the only force, and that is a very important part here. The only force acting, the only force is the gravitational force. Gravitational force is the only force acting on the object. Now, question 2.2. Calculate the final velocity of Tom A when it hits the water of the river. So let's answer that question real fast. Now, here we are. Let's first of all write the data we have. Now, the height of the bridge is 200 meters, and therefore that will be the displacement the stones will take. So the displacement will be 200 meters. Stone A was thrown with a velocity, initial velocity, equal to 5 meters per second downwards. So we are going to take down as positive for the entire question, because everything is moving down, so obvious all this is down. What other data we have? We have that acceleration due to gravity is equal to positive 9.8 meters per second square. Alright, we are looking for the final velocity. So all we have to do is go to the formulas and select one that can help us. Now in this case, the best one is this one that say final velocity square is equal to initial velocity square plus 2 multiplied by the acceleration multiplied by the displacement, okay? And we are going to substitute, guys. And because they ask you for velocity, you must write direction. I was going to write downward, but downward will be much better. So this is question 2.2.1. It's not too bad. Let's see question 2.2.2. Calculate the time taken for ball B to hit the water. So now we are looking for the time of ball B. So it's question 2.2.2, okay? And we are going to quickly write the data here. Now this one is for stone B, okay? So what do we have? Displacement is going to be the same, is 200 meters, positive, down 4, positive for the whole question. The initial velocity is not going to be 5, it is going to be 20 meters per second down. It's positive then, positive, positive. What else we have? We have that acceleration due to gravity is positive 9.8 meters per second square. And we have that we are looking for the time. That is important to know. So when you go to the formulas, what would be the best formula to use here? It must be one that have time, guys. It must be one that have times, and you don't have the final velocity. So saying that, the best formula to use is this one that states that the displacement is equal to the initial velocity multiplied by time plus half the acceleration due to gravity multiplied by time to the power 2. Now, when you substitute here, you will have and when we come here, guys, we are in a quadratic equation. And this quadratic equation will follow the same part of ax squared plus bx plus c is equal to 0, in which you have here a, you have here a b, and you have here c. So saying that, we can also use the equation of x is equal to minus b plus minus square root of b squared minus 4ac divided by 2a to help us calculate the time, because we have in a quadratic equation here. This is not too bad. It's not too bad because these days you have calculators, I told you once before, okay? So we are going to take this one and then substitute for the time. Now, if you substitute the positive, the answer you will get is a 4.67 seconds. And if you substitute the negative, then the answer would be equal to minus 8.75, but you cannot have negative time. So this answer is incorrect, and this one is the correct answer for the time. Guys, it's not too bad. It's not really that bad. So let's go to the next question. This one is not the first time we do work like this, okay? Let's go to the next question, which is 2.3. Calculate the time elapsed when stone B passes stone A. Now, we previously calculate something very similar, but in this case, they are asking you, because other time they ask you how high from the ground are the balls when they meet each other. Now, they ask you at what time are those two balls meeting each other. That is the question here, time elapsed. At what time the balls are going to cross or pass each other. That is the question here. It could be tricky. So this is question 2.3. Now, what we need to know, we already know that one because we did it. We did this question before. Or let's say not this question, but a similar question. Now, what do you need to know? When ball B passes or crosses ball A, then they are going to be at the same position from the ground because they are crossing each other. So at that certain point, if this is A and this one is B, they are going to be at the same final position. Now, if we take the initial position as the release point instead of the ground, we're taking now the release point as the reference point. For instance, this one is the initial position, let's say, for A and B. And this one is the initial position for A, which is equal to 0, and the initial position for B is also going to be 0. But eventually, they are going to be at different positions from the release point. So this vector here will represent the final position of ball A, and this one, this vector quantities, and this one here will represent the final position of ball B, this one A and B. And at that specific point, at this specific point, the positions, as you can see, are the same for A and B. Position final B. They are at the same position, guys. Okay, so I hope that is understood. This part here is not important for now because we're working from the release point, which is this point here. This is release point, okay? So we're working from the now. There is also something important to know. They are telling you that ball B was thrown 1 second later. So that means that the time B will be equal to time A, but minus 1 second because time A was 1 second before. So this is also important to know here, otherwise you cannot solve the problem. So saying that, let's start now with the solution here. So what we have, how we starting? We say that final position of A will be equal to final position of B. The formula for position, remember, I'm going to write it on this side here. Position, final position is equal to initial position, not velocity, initial position plus the displacement, any formula for displacement. And in this question, the initial position for both of them is equal to 0. So because of that, we can say that the displacement, we can use X or Y, it does not really matter. Let's use a Y here. Displacement of A will be equal to the displacement of B because of this one there, because the initial position is 0 for both of them. So what formula for displacement we can use? The same as the previous question. We can say that displacement is equal to the initial velocity, because it's what we have, multiplied by time plus half acceleration times square. And this is the formula we're going to use in both cases here. And this is the answer. So this is the time at which the balls meet each other. This is the answer for this question. It's not that difficult. We did something similar before, guys. Now, the last two questions say draw a position time graph for the motion of both stones and draw a velocity times graph for the motion of both stones. So we have to draw two graphs, one of position for both stones and one of velocity for both stones, and then will be the end of this video for now. So question 2.4, we're going to answer that one real fast. All right, so let's draw ball A and let's take the release point as the reference point. So this 0 here means release point. So that is point from which it was thrown. Now what does ball A does? Ball A move all the way like this here. They don't say what direction you can do that, but this will be a good option. So the total time for ball A is unknown, and this here will be just the water. So here is a 200 meters. Okay, now what we need to know that the balls are going to meet somewhere. All right, ball B is going to be released 1 second later. So this is 1 second later, and ball B, because it have a greater velocity, will reach the surface of the water before the other one. So it will move here, they will cross each other at some point and go all the way to the same displacement. This one is for ball B, and this one was for ball A. Now this time here that you see here is the time where the balls cross each other, which is 2.9 seconds. Now remember also to have the final speed of the object. Remember, this is not accurate, né? So let's move it here. Is at 2.9 seconds, and here is the final velocity for B, which we already final velocity, no, sorry, the total time that B took to reach the ground, which was 5.67. Remember, I am telling you this one now, I'm not drawing at scale, so this is not accurate drawing. It is just for you to understand the drawing and what is going on there, guys. Okay, so now this is 2.4. 2.5 is the velocity times graph. Now what happened here? The initial velocity of ball A is 5 meters per second, and ball A is going to increase its velocity up to it reaches the water surface, which we did in actual fact calculated, and that velocity of A is known to be 62, so this final velocity for ball A, this is A, is 62.81. Now what happened? 1 second later, ball B was thrown, and ball B is going to be thrown from not 5, but it's going to be thrown with 20 meters per second. Again, I say this is not accurate. It was thrown 1 second later. So this is thrown from here, from there, because it is 1 second later, and the lines must be parallel. Okay, so note that it must reach the same point. There somewhere there is this graph B. Okay, now what happened at this specific point here? The time for stone B, which is not the same as A, because this is the total time, A must be extended a little bit more, is going to be 5.67 seconds. And guys, this is the question. So this is question 2. Next time we'll move to do question 3, and that's it. I don't want to make videos too long, but I hope it helped. Thank you for watching. Time up, write messages. Mr. G here. I'll see you next time.